Hello, Algebra 2. Today we're going to do notes number 14, basic operations on polynomial functions. The essential question is, how does function notation help us simplify writing and understanding math questions? And at the end of this video, you should be able to say that you can read function notation and understand when to add, subtract, or multiply functions together. So tonight's homework is assignment number 15. It's 5 problems at the end of this video. Okay, so make sure you have a piece of paper out and it's titled number 14. I want you to listen for just a minute. So we got to make sure that we understand what standard form is. So standard form is when you write by the exponent. So x to the third would be written first, then x squared, then 3x, and then just the regular number at the end. So you always start with the highest exponent. So the x to the third, then the x squared, then x, and then no x. That's called standard form, descending order, okay? And then I think you already know that the degree of the polynomial is third degree because it has x to the third, and then the leading coefficient is the number in front, okay? So the degree of the first term is a third degree, then this is the second, this is the first degree, and this is 0 degree, okay? All right, so when you have to put something in descending order, then you would want to write this first. That's why it's written over here as x to negative 7x to the fifth. Then you would write the x squared item next, and then the x, and then just the regular number at the end. So that's descending order, okay? All right, so on your notes, I want you to write down this example and put it in descending order. I'm going to give you a second to do that. Hit pause on the video. Okay, so for descending order, you should have written this term first, so 2x to the fourth, then the negative 5x to the third. Make sure you bring the negative sign with it, that's right here, right? And then the negative 4x, and then just the number. Okay, so that's descending order, standard form. Okay, so on your notes now, I would like you to copy down this box, and we're going to fill it in. So make a little box, hit pause on the video. Okay, so operations on functions. So f of x and g of x can be any two functions, and a new function h of x can be defined or created by performing basic operations and compositions on the original f and g functions. So if you see this notation, what it means to do, and you're supposed to be writing all of these down for your notes, is you just take the f of x function, and right here you can see you're going to add it to the g of x function. So you're going to add your functions. The next one would be to subtract your functions. So it's f of x minus the g of x. And then when you see this right here, it's for multiplying your functions. So that's just f of x times g of x. So make sure you have all of this down for your notes. Okay, so this is going to be your notes. So you can draw a big box on your paper. You're going to need some room. You can also print this piece of paper. If you go back to Google Classroom, there's a PDF file that you can print this. So you have a print option if you'd like. If you're not printing it, hit pause and you have to write all of this stuff down, and I'll give you a minute to do that. So hit pause on the video. Oops, I have a typo. This one should be a plus. Careful, I had a bit of a typo right here. It's to be a plus. Okay, so I hope you're ready now. what I'm going to do is I'm going to use these two functions right here, and I'm going to do each one of these examples. This is supposed to be example 2. We had 2 typos on here. It's supposed to be example 2, you guys. Example 2. 3, 4, 5. Okay, make sure it's a plus sign. So I'm going to go ahead and do those, but I'm going to do them on a separate slide. So I'm going to switch slides, but I'm going to work on this one first, and then we'll go over and do example 3. It just gives me more room. Okay, so here's example 2. So you're supposed to add them. So it's just going to be 7x minus 10 plus, and then I'm going to put the negative 3x squared. Oops, I don't have enough room. Plus negative 3x squared minus x plus 7. So I got that from right here. I'm going to draw a line. So did you notice how I lined up these 2 items and these 2 items? Right? So there's nothing above the 3x squared, negative 3x squared, because there isn't another term with it. So these are like terms. Now the other thing you might want to do is fill in a hidden 1 right here. Okay? So just add and subtract. It's just like the same as combining like terms. So negative 3x squared comes down. And then how much is 7x's minus 1x? That would be 6x. And how much is negative 10 plus 7 is negative 3, and that's our final answer. Okay, so now we're going to do example 3. Now it says to do f of x minus g of x. Now when you subtract, you have to distribute the negative or add the opposite. So we're going to write down 7x minus 10. And then we're going to add the opposite. So I'm going to add, and now instead of having negative 3x squared, I'm going to do the opposite. Instead of negative x, I'm going to do positive x. Instead of positive 7, I'm going to do negative 7. So I have to add the opposite. So you look to the problem. Before you write it down over here, you have to change the sign. It's the same as distributing a negative. So we have to add the opposite, and you only do that on the subtract problems. Okay? So remember there's a hidden 1 right here, and then you just think up and down, up and down. So this would be 3x squared. 7x plus 1x is 8x. Negative 10 and negative 7 more is negative 17. And this is our final answer. So you have to add the opposite when you subtract. Let's do another one. So example 4 is another subtraction. So I'm going to write down the g of x function first. So negative 3x squared minus x plus 7. Now I have to, for the subtract, add the opposites. So I have up here, I have positive 7x, so it's going to be negative 7x. So you have to add the opposite. I have negative 10, so I have to put the positive. So add the opposites. This is what I have, and then I'm going to change it. So add the opposite, negative 7x plus 10. That's what I put up over there. Add the opposites. That's what it means to do subtraction in math. So negative 3x squared comes down. Negative 1x and negative 7x right here is negative 8x. And 10 plus 7 is 17. So each one of these we're getting different answers. Okay, depends if we're adding or subtracting. Please remember to add the opposite when you have a subtract sign. All right, and here's the subtract sign right here. Subtract them. Okay, next one. So now we're going to do example 5. It says f of x times g of x, and we're going to use the box method. And we've done this before in class. So we're going to take the f function, 7x, negative 10, and put it on the side. We're going to multiply it by the g of x function, which is right here. Put that at the top. Now remember, when you multiply, that's going to be your first step. Then you change the exponents. You have to remember to change the exponents. So we're going to take 7x and multiply it to the negative 3x squared, then to the negative x, and then to the 7. When we're done with that, we're going to take negative 10 and multiply it to that negative 3x squared, to the negative x, and to the 7. So that's the path we're going to follow. So let's get started. 7x times negative 3x, so 7 times negative 3 is negative 21. X times x squared is x cubed. You have to change the exponent, right? So x times x squared is x3 because there's a hidden 1 there, okay? Okay, next one. 7x times negative x, that would be negative 7. X times x is x squared. So remember, x times x equals x squared because it's x1 times x1, and you're adding those hidden ones, right? Okay, the last one, 7x times the back 7 would be 49x. Okay, now we're going to take negative 10 and multiply it up to that top blue, negative 3x squared. So negative 10 times negative 3 is positive 30x squared. And then the next one, negative 10 times negative x. Negative times negative is positive 10x. And the last one is negative 10 times positive 7. So it would be negative 70. Now, your answer, let me change colors here real quick. This is always your front part of the answer. This is your back part of the answer. So let's get our final answer started. Okay, so negative 21x cubed is our front and negative 70 is in the back. Now, you just go ahead and, whoops. Oh, hold on a minute. There we go. Now we're going to circle like terms. And now when we add and subtract, do not change the exponents, okay? So you only change the exponents when you multiply. So when you add or subtract at the end for the final answer, don't change the exponents. So 30x squared minus 7x squared right here. 30x squared minus 7x squared. That would be a positive 23x squared. Next one. 10x's plus 49x's would be 59x's. And there's our final answer. Multicolored. It's 2 different colors. Okay, so we changed the exponents on when we were working in the box. That's when we change it, when we're working in the box. But when we add and subtract, we just do the front numbers, the coefficients, right? Okay, you have homework tonight. So you have 5 problems. Make sure on number 4 and number 5 you use the box method. And then upload both your notes and your homework during async period today. Let us know if you have any questions. Thank you.